Second try. Now we're recording. So you have your site model, you have your Grasshopper opened up. And what we want to do is we want to extract a portion in which you would like to work, right? So first of all, you can just hide the mesh for a bit, and just looking at it from the top view, navigate yourselves to which area you actually want to kind of work in. If you are unable to read the map, let's say it like that, or the site, let me help you out. So this is where we arrive. This road is through which we arrived to the site. This was the parking lot area, or wait, a little bit finicky, but around here was the parking lot area. And then we kind of walked around here, and this is the hill, right? The hilltop. So we kind of walked around this edge of the hill, or probably around this right here. And that's the staircase? Maybe no, probably not. I don't know. It's old. This is an old drawing. But so you can kind of position yourselves, kind of understand where things are at. And what I suggest you do is just create a new layer and call it like boundary or something like that. Boundary. Go to that layer and draw out a rectangle or any kind of a form. Not any kind of a form, but any kind of a proportion of a rectangle where you want your site to be. And it doesn't need to be super small. It can be pretty damn big. So I will just say I want to deal with this side of the hill. So I'm just going to draw out something like that, maybe. Bam. So I'm going to kind of work with this area. Later down the line, so this is just for design purposes, and you will be just kind of designing in that area. And the reason why we're doing this is if you were working on this with this whole mesh right here, it would get in the way too much, right? You would constantly need to kind of hide the mesh, and it's too big, too bulky, it's hard to rotate around it, and so on. So what we're going to do is we're going to just say, during my design phase, I will be just working on this area right here so that it's easier for me to rotate around and kind of position myself. Once I'm done, I might, for later down the line for renders or whatnot, I might kind of take this area, for instance, and kind of rebuild the site from here. That is absolutely doable. But for now, we're just making a small one. So once you've done that, just having a rectangle here, actually we can go to perspective view because that's going to be a little bit more convenient for us. And let's just drag up this border that we have, this boundary, just up, not to the side. I hide the mesh. So this is the mesh, right? So I just select it and I hide it. And now it's gone. Or are you talking about how do you hide the mesh edges being displayed, but the mesh still being shown? No, I just, every time when I don't need the mesh, when it's getting in the way, I just select it and I just hide it. And if I need to show it again, I just type in show and it's back, right? That's constantly, yeah, that's usually how I work. So now we have our boundary, which is somewhere here. There we go. It's here. And in my case, it's flat. If in your case it's not flat, just scale it along the z-axis. Let's say if your boundary looks something more like this, if it's all messed up, just select it and scale it along the z-axis by 0. Flattens it out. kind of a useful little thing. And now I'm going to start hiding a few layers because there's a lot that I don't need. So I'll hide the helper layer, the side lines, projected lines, and 2D lines. So now I'm only left with the mesh and the boundary. And honestly, I'll change the boundary layer color to something like green, just so that I can see it, you know, and it's not getting suffocated by all of the mesh edges when I look at it from the top. And I know that for some of you who only have one screen, it's rough trying to follow along. So I'm just giving you some time to kind of do it. Oh, by the way, since we're dealing with Grasshopper, the boundary that you right now draw, that rectangle, you will easily be able to just move it around and extract a portion, you know, in real time from anywhere on the mesh. So it doesn't need to be super precise. You're not making a decision right now that you can't change later, right? So just draw. You can have it anywhere, as long as it's above the mesh. By the way, if there's one limitation to our approach, if you have this boundary and it's doing something like this, right? Where a part of it is sticking from the mesh, it's gonna break. The definition is not gonna work, the Grasshopper script. So we do need it to be kind of, the whole boundary needs to be right above the mesh. It can't stick out in the top view. Okay, so now let's turn on Grasshopper. So I already have it here, and you probably do so as well. And I will get both of these into Grasshopper. So I'll reference both of these geometries into Grasshopper. I kind of talked about it a little bit during our previous, not previous, but previous course about Grasshopper and how it kind of works. But just to touch upon it really fast, Grasshopper is basically a set of commands that have visual representations, and they are represented like nodes, right? And what you can do with it, it's basically you make these chains of commands, which are called definitions, for any kind of geometry that you get into Grasshopper or reference into Grasshopper from Rhino. And then by the action of baking it out, how it's called, you get the modified geometry back into Rhino. So Grasshopper is just like a fancy tool within Rhino that has a set collection of operations or tools that can be applied to geometry, right? So even in Grasshopper, you have stuff like offset, you have stuff like extrude, and so on. And it's all, the difference is that in Grasshopper, it's all automated, right? And it automatically extrudes and it automatically offsets. While in Rhino, you kind of need to write, you know, the command. Will make much more sense once we actually use it, and I'm not just talking about it in a blank screen. So let's reference it in. So we have a mesh here, and we have a curve here, right? So any kind of polyline doesn't matter. It's a curve, right? A circle is a curve, a polyline is a curve is a curve, and a mesh. So to get this into Grasshopper, we need to create two nodes, one called mesh and one called curve. And those nodes are can be found under params here, under geometry. Here you have all of the different data types that that Grasshopper can read. Let's say it like that. So Grasshopper can read points, can read vectors, circles, arcs, rectangles, planes, blah, blah, blah. Some of these are kind of confusing because a line a circle, a arc, a rectangle, all of these can be curves, right? So some of these nodes can hold more than one type of data. The one that usually holds any kind of geometry is called a geometry node. And you can use it, but I kind of prefer to have them separated. So I will just say, give me a curve component. So this guy right here, curve. Or you can, by the way, a shortcut for it is double clicking and typing in curve. Just double clicking anywhere on the Grasshopper canvas and typing in curve. You will see a component that has a hexagon icon, a black hexagon icon. Black hexagons for icons means that that component doesn't do anything. It just holds data. It just holds information, right? So it's kind of, it's a little bit tricky to get into, but once you go over the first hurdle, then you see that there's like 50 more hurdles to go over. Ain't gonna lie, it's not the most pleasant journey getting used to Grasshopper. Those of you who see the node of curve this way, you can change it to have either a full name or to just show an icon. If you go to display, here you have draw icons, this little thingy right here, draw icons. If you click on that, it will show this node as an icon. I strongly suggest you don't do that as you're learning Grasshopper, because you'll have absolutely no idea what's going on, right? At least here it just says what it is. Icon, once you get used to it, icons are good because they are compact. But right now we don't do draw icons. We have it like that. And also I would suggest going also to display and choosing draw full names like that, just so that you get all of the possible visual information out there that Grasshopper can give you. So this is a curve component, and this is a curve. We need to tie them together. The way you do it, just like we did in the previous course, you right-click on the curve component. You choose to set one curve. In this case, it's one curve, right? That rectangle that we drew, it's one closed curve. So set one curve, and you click on the rectangle right here. Bam, that's it. Now they are connected. Congratulations. You can now apply different things to this curve, like offsets, extrudes, and whatnot in Grasshopper. And it is going to kind of create geometry for you. Well, you kind of know how it works. You used it. Now we will do the same thing with a mesh, and I will be a little bit faster, right? So I will not go into geometry tab here, even though I can go here and find the mesh. I will just double click and type in mesh and find the one that has the black hexagon. Right click on it and choose to set one mesh and click on my landscape. And it turns green. That's because I have it selected. If I unselect it, it turns red, right? So things that are selected will get this green, or nodes that are selected will show up green in Rhino. Okay, we have this done. So now, since I heard something. Hello? Ah, yes. Wait, let me fix that. There we go. I fixed it. It's just, those things are how long did it take for each of these nodes to calculate, and you don't need to have them. It's used when you are trying to make a script that works fast, and you need to figure out which part of it is slow and kind of redo it. It's unimportant, absolutely. Okay, since we have a curve and a mesh here, we don't really need to look at them in Rhino to have the geometry shown for us in Rhino. So I'll just select both of them and type in hide. It still kind of shows us the Grasshopper version of it, you know, the linked Grasshopper version. So might as well just look at it there. One more thing is in Grasshopper, you can get rid of looking at the mesh, how do you call it, mesh edges, because this is a mess, right? This is so many lines. So you can opt out from displaying them. If you go to display, you can choose preview mesh edges right here. Preview mesh edges, and if you click on that, it's not going to show you the edges anymore. So it's going to be just visually a little bit cleaner, a little bit nicer. Okay. Yes. No, I hid all of the geometry. Basically in Rhino, I don't have any geometry displayed at all. Everything that I have is in Grasshopper. And that's usually how I work. If I work with geometry in Grasshopper that's referenced from Rhino, I will make sure to hide it in Rhino so that I don't get confused, especially if I'm changing some things and things will start overlaying on top of one another real fast. So I try to visually clean things up as much as possible before working. Okay, so this is what we have. And we have our little hill here, that's nice, and so on. So now, let me talk to you about the logic, what we're gonna do. And how do I talk to you about it? Is there let's do paint. Because paint loads up faster than Photoshop. And I'm gonna use paint to draw. Okay, so we have our, and I'm gonna draw it in 2D. So we have our landscape, right? And we have, let's say, our rectangle. Oh God, this is gonna be hard. Oh my God. Okay, so we have our rectangle floating above our landscape. And what we want to do right now is we want to extract this portion of the landscape, right? And kind of rebuild it into a surface. So there is one technique in Grasshopper that is called surface from points. And basically the way it works is if you have a grid of points, and it needs to be a grid, and the grid is basically rows and columns, right? If you have a grid of points, it will generate a surface for you through that grid, right? Like that. Close enough. you get the idea, right? So as long as it's a grid, it will generate a surface for you. So the thought is, if you look at a grid, from the side, you kind of see a row of points. So that there's a point there. So what if we create a grid inside of our rectangle, like that, and we push that grid downwards? Each point is getting pushed downwards until it hits the landscape, right? Like that. Then we will have like a point cloud that is a grid following the landscape exactly at that area. And then we can use that surface from points command to create a surface. And that's basically the logic of it, right? So we have a rectangle in which we create points. We plop them down on the landscape downwards. That's why, by the way, we lifted up the rectangle, and we will rebuild a surface from that. Should be super simple. So first thing to do is to create a grid within our curve. And if we just, right now don't follow along, but you might think we can do divide curve, right? Divide curve, but the problem is that it's going to be cheeky about it, and it's going to divide only the perimeter because it reads it as a curve, right? So this doesn't work. We need it to read it as a surface. Well, thank God we flattened it out and we made sure that this is flat, because we can make it into a surface if we just say boundary surface. This is same thing as boundary surfaces. That's the command that we want to use. It's basically the same thing as planar SRF in Rhino. Why doesn't this use planar SRF as well? I have no idea. Some commands are different in Rhino and Grasshopper, which do the same thing. Maybe they don't talk inside of the company, I don't know. But it is what it is. So we have our boundary surfaces, which basically, it is a command, it is a tool, and it asks us for one input and will give us one output, right? Inputs are always on the left-hand side. Outputs, after the operation has finished, is always on the right side. So on the left side, we have edges. And here, we do have edges, right? We can use this as our edges. So what we do is we just straight up connect curve to edges. That's it. It spits out a surface for us. That was easy. And now, oh, by the way, since it's parametric, right? If I show and I grab this, in Rhino, I grab this curve and I kind of move it around, of course it's gonna, the surface is gonna follow. This is why I said that we're not making a decision right now where to place your site. We're just making a tool for generating the surface for the site. Hide that again. Okay, so we have our surface. That's step one. Step two is creating a grid for it. So creating a grid, you might, again, go through all of this, all of these tabs and find here under vectors, find grid and try to use that. But that only works on flat ground on the XY plane, well, by default, on XY plane. In this case, you want to create it on a surface. So here you actually use divide surface. And that little icon that you see there actually kind of shows, divide surface icon, the orange one, actually shows a grid on the surface. So that kind of gives you an idea of how it's going to work. So we choose that, divide surface. Oh wait, chat, is it also possible to make the boundary box bigger or smaller later on? Yes, absolutely. So the size also can be changed. The only thing that can't be changed in this case, it will need to always be a rectangle, some proportion of a rectangle. That's because, well, you need the rectangle to be divided up to get a grid. If you divide up a hexagon, it's not gonna be a grid, it's gonna be something weird. And also it won't work. It's not gonna divide a hexagon for you. As long as it's a rectangle, it can be anything. Divide surface, and basically asks us for three things. It asks us for a surface. Well, so we just connect our newly made surface to the surface input right here, like that. Immediately gives you a grid. Why does it immediately give you a grid? That's because the U count and the V count is 10 by default, set to be 10 by 10. And if you count these points, you will actually see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? And here it says 10 and it gives you 11 by 11 points and you get confused and then you read and then you think and then you understand that this is not amount of points, but rather amount of divisions. And I do need to kind of explain this to just be pedagogical about it. When you have a curve, again, I'm not showing it on a surface because drawing is too hard. When you have a curve, and it's not divided up, you have 2 points. Start point, come on, why can't I? Hello. The start point and the end point, right? Why are you not letting me draw? There we go. So that is one division, right? It's or rather one segment. It's not divided up at all. If you have two segments, right, like that, it's going to have 3 points, right? And you kind of can guess where I'm going with this. If you have 4 segments, or even if you have 3 segments, it's going to have 4 points. If you have 4 segments, it's going to have 5 points. It's always going to have one extra point right at the end, according to how many segments you have, right? How do we get the full text to show on the boxes? You already answered. Good. good. So that is why you count doesn't match with amount of points. It's always one less, or other way looking at it is amount of points is always one more than the numbers that you give here. The reason why I'm telling you this is because in this instance, it will not really make a difference that much, but later down the line, that one little point that is extra can really screw you up, right? So you need to be mindful of that. This is divisions. Okay, so I'm going to just create a slider, a number slider that can describe the number of divisions that I want. And I'm going to do it immediately as a shortcut. So there's the long way of how to create a slider, and there's the smart way. So I'm going to just teach you the smart way, and we will ignore the long way. So the way you create a number slider in Grasshopper, it's basically you write the smallest number that you want to have in that number slider. So in this case, I will write 1. That's the smallest number. Then you write ... 1 ... and then you write the largest number that you want in your slider. I'll write 50 for now. Not 15, 50. And hit enter. And then it creates a number slider for me between 1 and, if I drag it like that, 50, right? That's the fastest way, and that's the most convenient way. I will not even talk to you about alternatives. So now we can connect that number slider to both U and V count, because I'm lazy in creating a second one, so we'll just use the same slider for both of them. Connects to U count and connects to V count, right? And now I have 20 by 20, and as I move that slider, I can increase or decrease the resolution, right? The amount of points. So I'll stick to 50, honestly. One dot 50. That's the shortcut, yeah. So now we have, and then I just connect it to U and V so that I can control like the amount of divisions in both directions at the same time. Because I don't want to do it separately. Anyway, we end up getting 3 outputs here: points, normals, parameters. We don't care about normals, we don't care about parameters. All we care about is points, because points are going to be the thing that we are going to push down on this landscape, right? On this mesh. So points. I'm just thinking, how should I do this? Because there is one thing right here that I really don't want to explain to you, because that is going to take like 2 hours. But I have done a YouTube video about it. Let me not explain it. And yeah, points. That's everything is fine here, and there's absolutely no problems whatsoever with this list. And we just move on, ignoring ignoring our problems. So I'll drag my landscape mesh closer to divide surface, because this is a moment where we will start using it. So now my mesh component is right here, and I want to push these points onto the mesh, right? So a tool that does that is called project. Project. And once you write project, there's a bunch of options for different variations of that tool. Just a regular project, project a curve onto a B-rep. B-rep is basically polysurface. Project a point, project along some sort of a direction, and projected force, that's a different thing. Don't worry about that one. So basically we have 4 options. The way we choose between these 4 options is we read the description, right? So with my mouse, I hover over these options and I just see project an object onto a plane. So on a plane means that on something that is flat, right? Doesn't work for us. The stuff on which we're going to project is not going to be flat. So we ignore the first one. Second one, project a curve onto a B-rep. Well, we have a mesh and it's not a B-rep because it's a mesh. And we have a bunch of points, but we don't have a curve. So that doesn't work. Okay, next one, project point. Project a point onto a collection of shapes. Well, mesh is technically a shape, and we do have points. Might as well use that. Okay, so we choose to use that. And that is literally how I worked with Grasshopper for 4 years. You type in what you want to do, and then you read the descriptions and find the one that sounds closest to what you want to achieve. So we have 3 inputs for project point. First input is point to project, right? And we do have our points here from divide surface. So we just straight up connect points to point like that. Notice that the dashed line, this is why I was contemplating if I should start explaining what this is, but I'll give you a link to a YouTube video. Let's save some time for SubD instead. So we have our point connected. Then we have direction for projection. If I hover over the input, I can see it says 0, 0, -1. The way we read it is 0 in x direction. So this is like the direction vector, right? So it's 0 in x direction, 0 in y direction, and -1 in z, right? So it's down. It's projection that is going straight down. And that works for us because we have our points hovering above the landscape, and they will be pushed down, straight down, until they hit the landscape, right? If you have your points hovering above the landscape, then you would need a different direction. And just to be kind of pedagogical about it, the way you describe direction is well, as long as it's locked to X, Y, or Z, you can just kind of double click, type in Z, and find a component that says unit Z, right? Unit Z, like that. Or unit Y, or unit X, right? That is directions. But in this case, the default value works for us, and we kind of stick to it. -1, it's fine. And the last one is geometry to which we project, or onto which we project. That's our mesh. So we just connect it like so. Bada bing, bada boom. We have our points projected. Now they are on the mesh. They are still a grid. It still works, but now they're on a mesh. Notice how visually I kind of see every step that I've done, right? So I see my surface right here. I see my divided points right here. And then I see my projected points. Grasshopper will show you, will keep showing you every step of the definition, right? And every node, the output of every node, it will keep showing you, right? So This is like a part of a parametric workflow. It's that since everything is kind of connected live, right? And once one thing changes, everything changes. These commands or these nodes are constantly running, right? So they are constantly showing you the preview of what they are generating, right? So right now, if I were to show selected, and if I were to just show the curve like that, and I take this curve and I move it to the side, the points follow, right? The projected points, at least. So that's kind of neat, and that's kind of cool. And by the way, I can indeed kind of make it bigger or smaller. That's fine as well. I will have it kind of dense though, just to have more resolution. Okay, so we have this going on. Now it's time to create a surface from these points. Oh, right, I was talking about visual issues, that there's too many things at the screen at the same time. So the way you kind of fix that is, and the way I really like fixing that, is selecting everything in my definition, just dragging over everything in my definition, holding down the control key and unselecting just the one, the last, let's say, node, or the one that we want to actually see. So selecting everything else, clicking the scroll wheel of the mouse, so like the middle scroll wheel. If you click it, you will get this menu. And in this menu, you just click on the blindfolded guy, which will disable the preview. It's not going to show up in Rhino anymore. Disable preview, and now it's clean again, right? So now we only see the output of project point, and everything else kind of turned dark gray. And if I want to kind of look at it, I can always click on the nodes that I want to enable preview for, click on them, make them active, click the scroll wheel and get the guy that's not blindfolded, right? And now it's displayed again. So this is how it works. Pretty straightforward. Anyway, can you say that again? Oh, you can't change the value. So oh, the boundary is not between 1 and 50, but rather something else. What's the boundary? What's the largest number to which it can get to? Okay, so if you just try again, if you double click anywhere on the canvas and you just type in 1.50, so no enter, no nothing, just 1.50, and then you hit enter, then it should create a slider that's between 1 and 50. Sometimes what you do if you're if you're kind of used to hitting enter after every command, like I am, you can just kind of double click 1 and then hit enter, right? Without the .50, and then you will indeed have a slider that's between 0 and 1. But this way it should work. And then the way you kind of reconnect it is you just delete the old one and connect the new one in. Right? Okay, no problem. So, creating a surface. We have our points here. We want to do surface from points, as I mentioned before. I think it's located under here. Nope, under here, the surface tab, and I think it's under utilities. No, it's not. It's under primitive. No, it's not. It's under freeform. Yes, it is under freeform. So I have no idea where these things are. Under freeform, surface from points, or you can just double click and type in surface from points. Either way works. I'll just give you a second. Surface from points. Has 3 inputs and 1 output. That is going to be a surface, and that's the output that we really, really want. So let's say you all have done this. So now it asks us to give it a bunch of points, and it asks us to give it a grid of points, right? And we do have our grid, and I know that this is not going to work properly, but I'll still try to do it. So we connect our point output to the points input right here. And this is kind of still orange. Oh, by the way, if a node is orange, that means it's a warning, or rather, the node is not producing any output. Yeah. If a node is not producing any output, then it's going to be orange. If a node is red, that means it has an error, right? Straight up, something's not working. If it's just orange, that means it probably doesn't have enough inputs to produce an output. So in our case, we gave it points, but we still haven't given it U count. So you need to think, the way this works, it's basically you give it a grid of points, right? And it's basically just a list of coordinates for Grasshopper. And it needs to know how many points are there in a column. And then it's going to say, okay, so if we have, let's say, 51 points in a column, then it's going to count first 51 points, put them in one column, count another 51 points, put them in another column, another 51 points. So it's going to kind of keep putting them into columns, and it's going to understand the extents of the grid. Or else it's just going to, it would just read it as soup of coordinates. So U count is how we make it clean it up. And honestly, we do have a U count here, right? And we do know that we're using 50 as our U count. So we can be cheeky about it, and we can reuse that number slider that says 50 and just connect it to the U count like this. And this is why I explained it what it means when the node is red beforehand. It's an error immediately. But this is actually correct, like a correct way of how to connect it. And I will just be explaining to you why this is red and how we can fix it. So just do this. So the first thing that you do when you see a red node is you zoom into it. You see this balloon here, and you hover your mouse over the red balloon on the top right corner of the node, and you read it, right? You try to understand what it's saying. And it's sorry, and it says the U count value is not valid for this amount of points. Remember my shitty drawing with the line and the points and the subdivisions and the difference between the divisions and the points, that you always have one extra point for, for every grid direction. That means that even though we have 50 here, this is spitting out a grid of 51 by 51 points, not 50 by 50 points, right? It adds one more point. So when we give it U count of 50, it doesn't make sense to it because it can't divide the total number of points by 50, right? Because it has 51 by 51 points. So the way we fix this is we right click on it, on the U count, and there's like 50 ways of how to fix it, honestly. But one of them is if you right click on the U count here, you can go to expression. No, sorry, let's do it a little bit more beginner level way. Sorry. Don't do the expression. let's just do it a little bit simpler. So we just need to add 1 to 50, right? So the way we do this is somewhere near the slider, I will just double click and type in plus, a new command that is plus, enter, that is addition, right? And then it basically, the way addition works, it adds two numbers together, right? So we will add 50, and we will create one more number, that is 1. So I just double click, type in 1. Like that. Easy. So 50 plus 1 equals 51. Yes, good. So we have addition, and instead of using 50, I will just holding down the Control key. You can disconnect, right? You can disconnect the you can disconnect the wires. So holding the Control key, I will disconnect the wire like so, and I will reconnect the added value like so. So at least now this is correct. It's still red, and that's fine, but at least now we know that we are feeding it 51 points, the actual number of points that we have. It is still red. Why is it still red? Because of this damn dashed line. How do we fix that damn dashed line? Okay, really quickly, I think it's in my blood. I must explain this. If you see a wire that is just gray wire like that, this means that one element or one number or one type of geometry is going through that wire, right? A single curve, a single surface, a single number is going through these wires. That is why these wires are just gray thin wires. If I have, let me just really quickly, cat, dog, mouse, really quickly do this. Sure. There we go. If we have multiple data items, if let's say we had 3 animals in this case, or 3 types of geometry, or 3 numbers going through a wire, or more than 3, any amount of numbers, it would be this kind of it will look like a double wire or a thickened wire, depends on how you look at it, right? So for one thing going through it, it's always just a gray wire. For 2 things or X amount of things, it's a double wire, right? And the way we call these, when you have more than one item, it's a list of items, right? So you have either a single item or a list of items. So a list has this double wire. So then the question is, what the hell is a dashed wire, right? Because how can you have even more complex stuff? Well, it's called a data tree, and it's basically a list of lists, right? So in this case, I have cat, dog, mouse, and then I can have a 1, 2, 3, and I can have red, green, blue. I'm just going to mimic a data tree for you real quick, and how it works. So you don't need to follow along with this. This is just me explaining the thing. So this is, as you can see, a dashed line, and this is a data tree, right? And a data tree is basically a list of lists. So we have cat, dog, mouse, that's one list. We have 1, 2, 3, that's another list. We have red, green, blue, that's a third list, right? The reason why it's called a data tree is if we look at the at how it actually kind of visually looks. It kind of looks like a tree, right? And it's basically cat, dog, mouse is in this branch, 1, 2, 3 is in this branch, and red, green, blue is in this branch. So that's how it works, right? 3 different types of data storage in Grasshopper. I will not be going deeper into this, but I just wanted to kind of explain it in the most basic way possible. The way we, by the way, so in this case, we also have a data tree, and that is rows of points in columns of points. Don't worry about it. We want to get rid of that information. How do you get rid of that information? Well, you right-click on the output, which produces a data tree, and you choose to flatten. Flatten means that it's going to take all of the items that you have and it's just going to push all of them into one list. So it's getting rid of that additional information on into which list the items belong to. So if I right-click on the result in this case and choose flatten, you can see that everything was pushed into one big happy family, one big list. Same thing will happen here. After project point, if the point output, I right-click on it and I choose to flatten, it just becomes a list of points, and then suddenly surface from points reads it, can understand it properly, and then it can interpolate a surface properly. So now I'm going to do the same trick again. I'm going to select everything except the last item, and I'm going to disable preview just to see my final surface here. So that's the surface that I have. Yeah, go ahead. Yeah, there is. Because right now, every time when I change the slider, it's going to automatically add 1 to this slider, and it's going to feed it into the surface from points. So it's kind of automating it, because if I had like 2 sliders, so if this is 17, then I have another one that's 18, and kind of, you know, it still works. But then if I change this to 23 or 27, it's red. And then I need to this is 27, so now I need to change this to 28, and it becomes tedious. So if you constantly add +1, then you don't need to worry about that. Yeah, just straight up automated. And this is like this number slider right now, as you can see, controls the resolution of the form. Is it possible to change? Oh, yeah. Changing the slider bounds. If you right-click, select the slider, right-click on it, click on Edit. Then here where it says Max, you can just double-click and type in 100. Accept, hit OK. And now it goes until 100. Keep in mind that if a mesh is low resolution, doesn't matter how many points you project on it, you will not invent additional additional detail on the landscape. All right, so at a certain point, this stops making sense. Increasing the value here that stops making sense. I think 100 still is kind of fine, still is good. We are like the difference between 50 and 100 really is visible, right? So we can really see it. So yeah, I would probably use something close to 100. And the larger, of course, the larger the rectangle, the more points you need, right? Because let's say if you have a rectangle that's 1 kilometer by 1 kilometer, and you have 100 points, that means there's 10 meters between each point, right? If you have another rectangle that is 100 meters by 100 meters, and you have 100 points, that's 1 meter between each point, right? So it needs to be kind of, the larger you go in terms of rectangle, the more points of resolution you need. But it's all visual, right? You just kind of increase the slider until you see what works. Okay, we have our form working. Now I can grab the rectangle and honestly kind of show you this cool thing. Now as I move the rectangle, I'm kind of cutting away a portion, any portion of the landscape that I want to work with, right? I think I can even kind of do this, but I wouldn't suggest it. Yeah, I can do this, but please don't do that. Just keep it as a rectangle. Very easy to break it that way. But it can be rotated, for instance. You know, if you want it to be rotated, of course it can. So that is, yeah. Wait, just a second. Just a tiny second. God damn it. Now it works? Okay. Okay. That's weird. But if it works, then it works. Okay. Well, that's good. I don't need to answer things. One last thing to do here is to bake out the surface back into the Rhino file. And for that, let's keep things tidy. So I will make a new layer and I'll call it surface. That's not how you write surface. That's how you write surface. Surface layer, and I will just make it some sort of a color that I will really notice, pink. Just, you know, to have a place to which I bake it out and that everything is tidy. And then you just go here to your surface from points, you right click on the output and you choose this egg right here that says bake. Click on bake, you find the layer to which you want to bake and you hit OK. That's it. That's as easy as it gets. Bam. Your surface is now here. Then honestly, so that Grasshopper is not getting in the way, once you've done this, I would probably just kind of disable the preview of the final one. You know, so all of the nodes right now in Grasshopper are not being previewed in Rhino, just so that it's not in the way anymore. And I would save the Grasshopper file, save document, doesn't matter where, desktop, landscape, save. That's it. And I would just close Grasshopper because I'm done, right? I have it. I have it done. I can turn on some lines just to see it better. You know, just to see if I'm messing up or not. Doesn't seem like I am. Seems like the surface is indeed following the ISO, the contour lines quite well. That means I do have a surface, a landscape surface with which I can work. And this is like the rest is literally what we've learned in the Rhino course, right? You can, if you want to make it into a solid, you can by just doing duplicate border, project to C-plane. I'm gonna go fast with this, but it's gonna be recorded, right? And you don't need to do it right now. I wouldn't. Delete input objects, no. So we have this going on, then I just loft between these two. Yeah. Now I can delete both of these, join these up, cap, to get the bottom, that's it. We have a solid form to which now I can start cutting in boxes or whatnot, you know. I think. Let's see. Boolean difference. Here. Yeah, that works. right? So we can do that. But we're not going to do that because we're working with a different technique. We are working with SubD geometry, right? So we will be doing something a little bit different. And from here on out, like from this point on, the way you work with SubD is up to you, and the way you work with the not the SubD, but the landscape is up to you. I will be showing you different methods of how to work with it, but honestly, you just find the one that works for you. There's no correct answer, is what I'm saying. Whatever works. Let's have a 6-minute break. So 11:30, we'll continue, and I'll show you some SubD things. Okay. Cool. Recording, yes, recording. The distance, or yeah, the size of the landscape is quite big. If I were to measure it, from here to here, I have 319 meters. From here to here, I have 204 meters, right? So it's a pretty damn big rectangle to deal with. And usually for, your design, you don't want it to be that big, but as a surrounding condition, to which you kind of can have the possibility of extension, you might want it. But something more realistic would be to have, let's say, I'm just thinking, scale 1D. So this rectangle might be 60 by 100 meters, or 60 by 80 meters, right? I don't know. I'm just kind of guessing. So 30 from the midpoint, meaning 60 in total here, and then scale 1D. 40 from the midpoint, meaning 80 here. So 60 by 80 meters is like that. And this really gives you the sense of the scale itself, right? And how, how big the overall geometry is that we have. So now I kind of made a boo-boo by closing Grasshopper too fast, because I want to extract the small version as well. So I will be coming back to Grasshopper. I'll type in Grasshopper, and thankfully Grasshopper remembers me and says, yeah, I remember, we used to work on this. And everything still here is connected. And I believe if I enable preview, okay, it doesn't work. So I need to re-reference in the curve, apparently. I don't know why. Looks like a bug, might not be, I don't know. But I will right-click on the curve component right here and choose to clear values. And then right-click on it again, set one curve, and set my new small rectangle again. That's it. You can see that it's making the, it's creating the patch, the new patch here. Small boy. Well, very relative term, small, considering that it's 80 by 60 meters. And I will bake it out again. Bake to the surface layer, sure. So now I have like two surfaces on top of each other. And this one has same 100 by 100 subdivisions, so you can see that it's much denser because it's smaller, but it still has the same amount of subdivisions. That's basically that from our Grasshopper script. I will save it again, I will close it again, and never think of it anymore. Well, until we actually need it again. Right, so back here, we have our surface node and we have our boundary, right? These are the two node layer. These are the two layers that we are gonna be using. And what I want is a connection between these two layers. So let's say, and from here on out, I'm gonna teach you a method of how to work with this as if this was I can do it. I can do it. Come on. A SubD based modeling job, right? Or design process. So if our site itself was SubD based. So we are going to say that our surrounding site, this guy right here, is going to be just a surface. We don't care. It's just going to be probably like a surface, and we will just use it as a backdrop, as a nice little surface. While the small one is going to indeed be SubD based. So it's going to be SubD geometry. So first thing that I want to do is I want to cut away a hole in this big surface for this small one to rest in, because right now we have like a double trouble here, right? Two surfaces in the same place. So I'm just going to take this curve and I will offset it. Trust me on this. I will offset it outwards by 1 meter, not more than that. So just 1. Enter. Click. So now I have an offset outwards for this curve. That is 1 meter. Right? I will go to the top view right here. I will select that outer curve, that offsetted curve. I'll type in trim and I'll click on, not on the small surface here, but on the big surface that is inside, the portion of it that is inside of this offsetted curve, right? So for instance, this edge right here. Click, and it just kind of, automatically it projects that curve onto a surface and trims away a hole in it. So now what we have is basically a high resolution landscape, a low resolution landscape, and 1 meter gap between them, right? We're building up resolution levels for our later on, way later on, our rendering purposes, right? So that we don't need to deal with insane resolution throughout the whole, 20-kilometer site. That would just straight up not work on your computers, or on mine for that matter. So we have these two guys going on here. And what we're going to finish up with is, actually, we don't need the boundary anymore. So I'll just make my surface layer, my active one, and I'll hide the boundary layer, just so that I just work on these two. And we will make the small one into a SubD geometry, right? How do we do that? Well, we can do either remesh, quad remesh, right? Make it into quads and then make it into SubD, just like we did with the 3D scan of the arm last time. Or we can, I believe under SubD tools, there should be, yeah, just convert to SubD, this option right here. It should work, right? YOLO. Are you SubD now? Yes, you are, but you are super dense. Okay, so that doesn't really. Or actually, I know that now I'm blabbing a little bit, but just give me a second. I'm just choosing between the two methods, which one is better. Actually, the one that I've just shown is better, so let me explain it much more thoroughly. There's a command that's called toSubD, and I've kind of used it before yesterday, but now we're going to use it again on this particular surface. So the way it's going to work, it's basically these edges that you see here on the surface, these are called iso curves, and they're not the same thing as mesh edges, right? They just kind of additional information, visual information that shows divisions along the surface. That's a very shitty explanation, but I'll stick to it. Let's just think of it that way. So when we do toSubD, the command on it, it's basically going to say that every SubD face is going to be located in between these edges, right? So here what we end up with getting is a very very high resolution SubD model, which is problematic because then the topology, if we want to join that very high resolution SubD model, that means our building will need to be very high resolution as well, right? And it becomes problematic because of that. So we want to lessen the resolution here. And the way we do that is actually pretty simple. We just select the shape, we type in rebuild, the surface itself, we type in rebuild, and here we just specify how many points how many divisions do we want to have along one direction and along the other. So what I'm going to do is I'll just rebuild it with probably half of the divisions, right? So here I have 101, I'll just say 50. 50-50 for U and V. And this is not some sort of a magical number. I have no idea if this is going to work or not. It's visual, right? So you visually kind of see how big the faces that you get are after rebuilding. And then if they are still too big or too small for your building, you can rearrange or rebuild the surface again. So I'm just doing 50 by 50 because I think that's going to be pretty close. Hit OK. So that's the new grid that I have. And now I will apply 2 SubD to it, 2 SubD, which gives me a bunch of settings here. First of all, it asks us, would we like to use the control points? Yes, we would. Mesh crease, no. Well, we don't care about creases, corners. The only thing that we care about in these settings is delete input. Actually, we don't care about the original surface anymore, right? We don't really need it. So I'm going to just delete input. I'll say yes. Yes, please. Delete the input. Delete input, yes. We hit enter. We have our SubD form. Doesn't look like it changed a lot, but now when I hit tab, I can see that it's actually, it does change from shaded to smooth version. Okay, we're so close. So now, after doing all of this, we can finally start messing around with, let's say, I'm going to just do something really stupid real fast. And you don't need to follow along because this is going to be me destroying the surface or destroying the landscape. But basically, I'm just going to draw a box, and let's say the box height is 3 meters, something like that. Just move it up. And we have it here, and then I want to join that box up with the landscape, and I can immediately see, let's do flat. I can immediately see that for this particular box, the landscape subdivision, while it's good for this direction, it's bad for this because I need more divisions here. So I'll preemptively insert edge right here. Come on, click, click. Insert edge here. Again, you don't need to follow along with this particular example. That's why I'm going a little bit faster. Insert edge here. I will get rid of the 1, 2, 3, 4, 5, 6, 7, 8 polygons in the bottom or faces in the bottom. I'll get rid of 8 faces in the landscape like that. Move the box a little bit down. So, and I could bridge the gap, or I could kind of move each point to its new location like that. That would work as well. Up to you. But I will probably just kind of select the top loop, select the opening loop, and type in bridge. Join, don't crease, one segment, hit OK. hit tab, and now we have a dimple in the landscape. But this means that now we have, the landscape is a part of the building, which means that we have quite a bit of control over how the building is joined with the landscape and how they connect, and the whole geometry works as one, which I think is, for a naturum, that really makes a lot of sense, right? That everything is kind of joined. It doesn't necessarily need to be kind of melting together like it is right now, but actually, let me show you. If I just, let's say, select this, move this down like that, right? Insert edge somewhere here, right? It's becoming sharper and sharper, and you have like this crease that's appearing here, right? So you can make it pretty kind of not intense, but pretty sharp by yourselves, or you can just straight up create a crease as well. Just selecting, for instance, this edge right here, crease, enter, tab. This is now super sharp, right? So there's like if you have a question, if can we make sharp stuff with SubD? Yes, you can. You just crease it and it's gonna be sharp. I would suggest beveling though, not creasing, because you always want to retain a little bit of that smoothness for realism purposes, but creasing is fine as well. So we still have 12 minutes left, so I will just really quickly show you one little thing here, and then we will break for lunch, and after lunch we will just do 2 more hours or 1.5 more hours, and then I'll leave you to just straight up work. Right? I will just that ribbon that goes through this whole thing, I will select it, inset it, mode as group, and I'll inset it by 0.1, that is 10 centimeters, like that, right? Is that 10 centimeters? That seems like it's doesn't seem like it's 10 centimeters. Oh, by the way, sorry, one thing. If you select one polygon here and you want to select a ribbon running through the whole building, right? But it needs to stop somewhere here. So you can select 2 polygons, right? As long as they are on the same line, and then double click on any polygon, Control Shift, double click on any polygon in between them. Control Shift, click, click. Awkward. Control Shift, click, click. There we go. And it's going to join them up with the selection of the ribbon. That's really useful in my opinion. Inset, mode group. Why is 0.1 so big? 0.01. 0.01 looks like that, huh? 0.1? Sure. Yeah, whatever. So that's 0.1, and then we can, let's just do extrude real quickly. Not extrude SubD, god damn it. Direction Z. Extrusion with SubD is a little bit limited in terms of the directions, as you can see here, but it's nothing that you can't fix manually. So I'll just extrude it by 1 meter, and you can see that these faces are a little bit messed up, but we can fix them by just selecting them and moving them to the side, like so. That's fine for a design phase. That's fine, and making it actually accurate is going to be just later on, not a problem. Actually, it gives us here a pretty nice crease possibility as well. So we end up with this kind of snail looking thing. I keep doing these, I don't know. I don't know why. So that is that. Do you have any questions so far? Yeah, sure. Bevel function, huh? Just a second. 0.2, enter, delete. I will bevel the hole here that I'm making. So I'll just bridge these two together. Hit OK. Now I have a hole here. So let's say I want this to be sharper, right? And if I want them to be sharper, I need to bevel the edge, right? To make it into a double. So let me actually just join in. So I select the edge that I will bevel. I type in bevel, hit enter. And then I can either use the mouse, but mouse is a little bit laggy and a little bit like the snapping is, I need to turn off the snapping then. And then it's gonna work a little bit better if I do it again, I guess. Bevel without snapping now. That's still pretty bad. So instead we just type in the radius of the bevel. So I'll say 0.01, that's 1 centimeter. Hit enter, and that's the bevel, right? Once I hit tab, I can see that now this opening is super, well, not super sharp, but it is much more sharp than this opening right here. You can see this gradient, emap. Time for some emap to explain. Whoa, that's my graphics card not being happy with amount of stuff that it needs to show. Let's try True Sphere. Jesus. Anyway, you can see the gradient here, and also how much sharper the gradient is here, right? So here you just have like these really, really sharp like zebra lines going on. And here they are much more apart, much bigger. Why is this? Is it because of the size? Wait, I need to investigate this. Hide, zoom selected, emap. Okay, that's a rave party right there. Okay, so this is bad. If you see something going on like this, that means the computer, the graphics card is not liking it. Question to the group: do you all, when you do emap on any kind of geometry right now, do you see like a shitty version of it, or is it fine? Does it look okay? It kind of needs to look smooth and nice and, you know, not noisy. Looks fine. Okay. So that is, yours looks noisy. Okay. So it's kind of a split thing. I think it depends on the graphics card and what kind of computer you have. The way we solve it is by looking at what's here, the numbers that we have here, under bottom left corner, world, X, Y, Z. Those are 3 coordinates that we are dealing with. As you can see, the X and Y coordinates are a little bit big. And the reason why they are a little bit big is because the WG file, the AutoCAD file from which the landscape was generated, was gotten from the municipality. And the municipality, like the way municipality encodes, not encodes, but the way they build up the site survey drawings is that they have actual correct coordinates in their DWG files for X and Y, right? I believe it's calculated I might be wrong about this, but I think it's calculated from the central post office. At least historically speaking, like all of the coordinates would be calculated from the central post office of the central town in the municipality of that area. But this was long ago. Maybe they changed it up. Either way, we are that's 197 kilometers away from the 000 in x direction and 6,172. Okay, so this is just doesn't make any sense. We are very, very far away from x and from 000. So how do we fix that? Well, we turn everything on, everything that we have in our files, every little thing. Everything is turned on, every layer, right? We type in show to make sure that everything is shown as well. We type in unlock, show and unlock, to make sure that once we grab everything to move it to 000, everything can be grabbed, right? So show, unlock, make sure that no layers are locked. And we are going to just Control A to select everything, or if you're a Mac user, Command A. Find a corner, let's say, of a landscape. Doesn't matter. Find some point which you want to be 000, right? It doesn't matter which point you choose. Type in M, hit enter, click on that point. Well, object snapping should be turned on. Then click on that point and type in 0. Don't even need to type in 000, just type in 0 and hit enter. And now your object has been moved to 000 coordinates. So it's not here on the screen anymore. How do we bring back the screen? We type in ZSA. ZS and ZSA are two different commands. Zoom selected, ZS, just zooms in to the object, to the selected object on your current screen. ZSA, zoom selected all, zooms into the selected object on all of your viewports, within all of your viewports. So ZSA, and we are now good. And I really, really hope that now the shading is gonna be fixed, or else I have no idea why it's still not working. Anyway, I will hide everything again. 2D lines, don't need that. Projected lines, don't need that. Side line, side mesh, no. Helper, boundary, no. I'll come back to my little site here. Little doodle thingy, noodle thingy. Emap this. Oh, thank God. Okay, it's fine. It works. So it's not noisy anymore. Right? Now it's nice and glossy. Phew, saved. Okay. So that is how you create oh yeah, last one is going to be joining up the landscape and the NURBS, joining up the extended landscape with the SubD geometry. And the way I would suggest you do it is you just select your SubD landscape, duplicate border, right, to get that curve, the perimeter curve of your SubD landscape, then duplicate border on the bigger boy to get the inner curve, to get this boundary right here. Make sure to unselect everything. Select the two, this curve right here and this curve right here. These two, and you just loft them together. Yeah, just agree to it. That seems fine. Hit OK. and it just kind of gets lofted, deleted. Join, but don't join in the SubD geometry just yet. Just join in the landscape. That's all you need. Oh, it messed up. Fine, we will sacrifice 2 minutes of our lunch to fix it. Undo, undo, don't do loft. Sorry, don't do loft. Instead of loft, you do still have those two curves, right? So what we're trying to do is those two curves will need to make a ribbon, right? A ribbon surface. That's all we need to do. So instead of loft, we will use sweep between two rails. That's a little bit more powerful tool. So I will draw a line segment. Doesn't matter where you draw it, but of course it needs to be between the curves, and it needs to be perpendicular to both of them, right? So 90-degree angle. So just a straight line segment between the two, like that. Oops. Then you select, or you don't even need to select. You just type in sweep 2. You select the first rail, which is your inner edge or inner curve. Then you select the second rail, which is your outer curve. And you select the cross-section curves. Well, you only have one that you just drew. So you select that. Hit enter. It tries to kind of make the ribbon, but the ribbon is going to be kind of messed up. You can see, well, you can't because I'm dealing with freaking pink color. I have no idea why I chose pink. We will choose black again, just so that we can see what's going on. Again, sweep 2. Now I'm gonna go faster. First rail, second rail, curve, or section curve, enter. It thinks a bit, it does it. And now you can see the ISO curves they start off quite well, but as I'm looking at it, they kind of mess up quite fast. So we need to add more slashes. What's called a slash, right? So I will not type in, but I will click on this add slash, like that. And I'll just say, so one can go here. I'm basically defining the direction of the ISO curves and how they need to be arranged along this ribbon. Another one goes here. So now this fixes that. Then I'll go, usually just doing it in the corners is enough. So 2 slashes per each corner, 90-degree angles. Go here, that's clean now. Now you, oh, come on. Now you, go here. Go here. That is also now clean. And last one, where we actually started. This one will only need one. Kinda. Well, let's do 2, just to be safe. There we go. That's it, slashes. Very useful thing. If loft fails, you do sweep 2, sweep between two rails, and it works. Hit OK. Join up the two surfaces into a poly surface. Keep the SubD geometry untouched. Don't join it in. I don't even think you can join it in. Because this is going to be like a place where you work and place which you constantly change, and the surrounding one is just going to be, environment, just for visual purposes. So that is that. I would actually, after all of this, I would sell CRV, select curves, and just hit delete to get rid of the curves, just so that I know there's my landscape, there's my inner landscape, and I'm good to go in terms of messing around with my form. What the hell did I do? Questions before we break for lunch? Go ahead. That's because the inner landscape and the outer one, they are they have a different resolution, right? And they also, the outer one, as you can see, has a sharp corner, while the inner one has a rounded corner. You will always, when dealing with different data types and different geometry types and different resolutions, you will always have that little bit of a misalignment between the surfaces, right? So I did this 1 meter ribbon, and I always do this to eat up that misalignment between the two geometries. Does that make any sense? Yep. Yep. So that's why we did it. I'm just gonna do a unicorn real fast. More questions? Mm-hmm. Mm-hmm. With Grasshopper? Oh, nothing. I just, before opening the... Oh, yeah. I just drew a rectangle. In the top view, I just drew a rectangle for the area that I want. In Rhino. Yeah, that was the only thing, yeah. Yeah, no problem. So I'm just making a really quick unicorn here. And for instance, okay, so one last example before our before the lunch. This area right here is now super smoothed out, right? And if I look at it with EMAP, you know, it's super smooth. So coming back to the bevel tool, if I were to take this and kind of select the perimeter, and I don't know why it's not recognizing it as a ribbon, I guess it's not. I can do bevel, and I can give it like 0.005, so 5 millimeter bevel. It's a very, very thin one. And same thing here, but here I will just give it a little bit more bevel. Let's say 1 centimeter, 0.01. Right? And I hit tab, and now I can see that this is much more pronounced, right? So there is, like, I am initially creating seams here for this horn, right? So that's how I work with it. And I think now, as we have created a bevel, now I should be able to select this. Yeah, now I'm able to select this whole ribbon. That means my horn can move here. As you can probably notice, the way you work with SubD is a little bit closer to being a sculptor, rather than, you know, starting from the brick and trying to build up a building from a brick, like you would in ArchiCAD or in Revit, right? So that's inherently two different methods of approach, and one is, well, let's say it like that. This is a much stronger method for sketching and for creating concepts, right, and ideas. The other one is much better for technical projects, right? For actually making things that are buildable, right? Cheaply. The keyword there is cheaply, because you're dealing with kind of slabs and blocks and whatnot. In here, everything would need to be custom made. But as architecture students, right now, you're not constricted by money. So go crazy, make a unicorn. Why not? You know. Yeah. Yeah, yeah, you can, but it becomes a little bit more tricky. It becomes a little bit more tricky because you constantly need to, as you're mixing SubD with the regular Boolean union, Boolean difference operations, or surface-based operations, you always need to convert SubD into a NURBS polysurface, and there's no good way of how to get it back exactly as it was before, right? Because there's the whole process of using quad remesh, and every time when you hear remesh, understand that you are losing information if you're remeshing something. So it is a destructive process trying to kind of jump back and forth between SubD and NURBS. Much better idea is to plan out, or actually a best idea is to keep saving instances of your SubD model, right? If you're planning on doing Boolean union or Boolean difference with polysurfaces, much better to have like layers saying version 1, version 2, version 3, version 4 of your SubD, so that you can immediately jump back in time to any version that you had before making that SubD into a NURBS polysurface and using the Boolean operations on it to make corrections to it, right? Because it's much better to have multiple versions. Main thing though is with SubD you can kind of achieve any result you want that you would have as a mesh. Oh, sorry, not as a mesh, but with a NURBS polysurface, right? The geometry can be like visually, not just visually, it can be the same, right? It's just a different way of modeling. So I can crease this, for instance, and have it, you know, have these four edges sharp emap. So now it starts looking like folded metal. So would I suggest doing SubD to polysurface workflow? I wouldn't suggest it, but I don't think it's a big issue as long as you're saving your process constantly, like in separate layers. Because this geometry is lightweight. It's very lightweight. That card that I've shown, actually, we will just have longer lunch. Let me just open it up. And actually, I do want to save it. Save. Yeah, replace. Rhino. Just a second. So now let's find that card that I've shown during the introduction. I think it's under other fun 3D card project. There we go. And let's look at older version of it. So this is like this is in progress version of that 3D model. And it's messed up. Why is it messed up? Oh, I know why it's messed up. Just give me a second. Come on, load in. There we go. Now just give me the object's color. Huh? So that's my form, and that's some lights here that I don't need. So doing this in SubD was more convenient than doing it with NURBS polysurface. Even stuff that you would usually use Boolean difference on, for instance, stuff like this, the incisions. It's just literally selecting polygons and extruding them inwards, right? to get that information. And usually with Booleans, you don't really do more than that, right? Usually just Boolean difference out windows and whatnot, right? Holes that are usually rectilinear. Which can be done with SubD quite easily, right? So all of this stuff right here is just straight up. Oh, that's a mess. But don't look at that. That's messy. But all of this stuff is just extrusions. You know, pushing vertices in, out, and so on. And it's once you get used to the modeling technique, I don't think you will need to use NURBS polysurface modeling, or you will. I don't want to lie. You all will be using NURBS polysurface modeling later on in the process, for sure. But at that point, you will not be changing the initial design, the initial form of your building anymore, right? And that's where I'm getting at. Sorry for the monologue. You separate it. You separate it. So for this particular car, the way I did it was if I grab a clipping plane and just look at it, the model of the car is empty. Well, it's not empty, but it's a solid model. It doesn't have any insides, right? So everything, like all of the surfaces here, are thin shells. So the way I would, for instance, separate this window would be me selecting the overall, like all of the polygons that I want. And this seems tedious, but it's actually like, what, 1 minute to do? So it's not that bad. Just selecting the perimeter of the polygons, and I don't want to waste more of the time, and just typing in extract SRF, extract SRF, right? So we kind of just extract the polygons that we want to have a different material, and we apply that material to those polygons, and that's it. Yes, yeah. SRF, as in extract surface, yeah, that's the same. I'll actually be showing you that, I think. Yeah, I will be showing you that after lunch. But let's go have lunch. Okay, so I'll start. There we go. So now I only have a short exercise left for today, because most of the day was used up by the landscape, and I think it's an important, it's an important thing. So it's good that we kind of spend our time working with it, and it's basically going to be how to think about these SubD geometries and how to use them in as a design, right? Because up until now, I just kind of did these solid forms, right? Like boxes, I would extrude boxes, I would connect boxes together, and it was always, these solid forms. And then when I needed to make a shell out of them, I would offset them, right? And then suddenly they're a shell. Offsetting is fine. It's gonna stay. I think it's a good approach to giving thickness to objects, but you don't need to build things up from solid objects for now. Wait, do we even need to? Oh, by the way, I added an eye for the. I don't even know what this is anymore. And somewhere between a snake and a turtle, I guess. Eating a fish or sliding over a fish, whatever you want. Anyway, this is a solid piece of geometry, right? Well, technically, it's a solid piece of geometry if we don't look at it from the bottom up. I'm going to show you how to deal with design while thinking about it as series of surfaces that are being connected together. I think MAD architect, the Harbin Opera House that I've shown you before by MAD architects. I think it's done more like a series of surfaces that are connected into an arrangement rather than a single sculptural shape that was, extruded, carved out, and then so on. So that's going to be another approach that I'm going to show. So I'll just create a new file actually. And that new file is going to be, I'll just choose no template whatsoever. Don't care about a template. Just wait for it to load up. And then in this new file, I'm dealing with, I'm working in millimeters. That's fine. You can work in any kind of units you want. The site model is in meters. Keep that in mind, but you can easily change your units by typing in units, right? And then changing them here from millimeters to microns, for instance. Don't work in microns. Also don't work in kilometers. Millimeters, meters, or centimeters is fine. Decimeters is awkward, so don't use decimeters as well. And please no inches. Anyway, we can do some surfaces, and yesterday or day before that, we kind of looked at tween between two curves, which creates a SubD surface. So there's tween two curves, which creates a surface, and also tween two curves SubD, which creates a SubD surface, right? So we're going to do exactly that, and I'm going to just show you a quick little example. I just need to plan it out because I haven't. That's me being lazy. Yeah, so let's start with a curve, right? And I'm just going to take a NURBS curve, I guess, or let's do a polyline. Let's do a polyline. So I'm just going to draw a straight line segment, and I'll start. So I'm drawing a polyline, and I'm starting to draw it from 0, coordinate 0, right? So I just type in 0, hit enter, and now it starts drawing from 0. I will zoom out because I know that my line segment is going to be long. So I've zoomed out. I'll hit F8 to snap it to enable orthographic snapping, so that's always 90 degrees. And I will give it a length now. And I think the length might be, let's go for 5 meters. So 5,000 millimeters. Enter. And then I'll just hit enter again. Come on, enter again. There we go. So I have a single line segment that is 5 meters long. I assume all of you can draw a single line segment that is 5 meters long. I will make it curvy, and I will mess around with its control points. So first of all, I need control points. Right now it just has start and end. So I will add control points by rebuild the curve. There we go, that's the menu. And I'll say, sure, give me 4 points. Delete input, yes. Everything else is whatever. Make SubD friendly. I have no idea what that means. Never seen this before. I need to investigate before I can teach it. So for now we have this turned off. Delete input. We hit OK. And now we have it deleted. So actually, sorry, one more thing. Rebuilding again. We chose the points. We didn't choose the degree. Degree is 1. From the Rhino course, you remember that degree 1 means it's a polyline, so every corner is sharp. Degree 2 means it's basically a polyline on steroids, which also has arcs, right? So every corner is defined by an arc, right? Which can still be exploded into series of elements. And then degree 3 is a NURBS curve, which is seamless, right? So it doesn't have any arcs or any straight line segments. It's just a seamless equation. Let's say it like that. So we will be using seamless. We will be using degree 3 and hit OK. Honestly, you always use either 1 or 3. 2 is very niche. You only rarely use 2. Sometimes you will get degree 4 or degree 5 curves, and I can't explain what's the difference between them and degree 3. So we ignore that they exist. There's only 3 degrees, let's say it like that. Anyway, we have a curve which has 4 points now. I will select it. If you don't see the points, you can always hit F10 to get points on. If you already see the points, just select the 2 points that are on the right hand side, right? So the end point and the one near it, right? These 2 guys right here on the right hand side. And I will move it up, and I will move it up by, let's say, I don't know, 3 meters maybe. Whoa, that's a lot. No, not 3 meters. Let's do a meter. 1000. Yeah, that's a little bit better. Maybe we can be a little bit more aggressive with this. So I'll move it up by 500 more millimeters. So 1.5 meters. Something like that seems to be okay. We have this. Now, I am going to... What's the plan? We're thinking of a plan. What if we have a wall that is vertical here and it becomes a roof here, horizontal here, right? A surface that's from vertical becomes horizontal. So then what I'm going to do is I will take this curve right here that I already have and I'll move it up. So holding down the Alt key, I'll click on the arrow that's sticking upwards, the Z-axis arrow, holding down the Alt key, that's important. And I'll type in, let's go for 500 again. Yeah, something like that should be fine. So we have something like this. So this is just, you know, a boring vertical wall once we loft it. But now if I grab the top curve and I grab the 2 points, these 2 points here on the right hand side, these 2 points here, and I move them down, move vertical, M, enter, V, enter, from this point to this point, and then move them. So now they are the correct height, but now I can move them to the side by, I don't remember how much. Let's do a meter. That's a lot. Let's do 500 millimeters instead. There we go. So now I have, you know, 2 curves that make up a surface that will go from vertical to horizontal, right? Kinda easy. It's just basically moving points around. Just like everything in geometry, honestly. So we have this, and I don't just want it to be like a regular loft because I will be using SubD geometry, and I said that I will be using SubD, what's it called? SubD, Sweep 2 SubD version of Sweep 2. So we can have a cool profile for us. So I'll be fast about it. I'll just create a polyline between the ends here. Just a straight line segment here between the ends. I will rebuild it. And this time around, I will rebuild it with 4 points again, but degree of 1, because I want to keep the sharp corners. So I have a straight line segment with 4 points. I will take 2 points here. Zoom to them. I'll take the 2 points here and I'll move them out by, I don't know, minus 250 maybe. Oh, that's very aggressive. Less, minus 150. That's still pretty aggressive, but I will take it. So I have something like a form like this, right? Nothing fancy. I'll kind of repeat the same procedure here for the other end of my 2 line segments, 2 rail curves. I'll just create a line, I'll rebuild it, 4 points, okay, and move them down, minus 150. So now I can kind of show you what kind of surface we can expect to get from this. Sweep 2. sweep 2 without the SubD part, just straight up sweep 2. Select first rail, that's my first rail. Select second rail, cross-section curves, this and this. Enter. Okay. Shaded view. You know, that's the surface that I get. It starts like that, goes along, and ends like that. Nothing fancy. Just nice. Okay, so we have this done. I'll delete the surface. I don't need it yet. We will be doing more because I want to have this a little bit more, a little bit nicer. let's just say a little bit nicer. So I'm going to grab the top curve that I have, and I'll move it up by not a lot, by something like 100 millimeters, let's say. Even 100 is a bit much. 100 millimeters. And I'll kind of repeat the process where these 2 points, right here, these 2 points align vertically with the rest, so that this curve also flattens out into a roof, right? So I'll just take these 2 points, move vertical, M, enter, V, enter, from here to here, right? So that it's not sticking upwards, and then to the side by, I don't remember how much I used. I believe it was 100. Yeah, seems like it. So now we have one more curve, one more rail, right? And we just keep doing it. We just keep repeating it, right? So I'll take this curve now, copy it up. I don't remember by how much. My memory is horrible. 500 millimeters it was. Okay. Up by 500, like that. Perfect. These 2 points move vertical, down, out by 500. Or actually, maybe we can do, let's do 500, that's fine. Or let's be fancy about it. Let's do 500 more. So it becomes wider here for some reason. Bigger roof, I guess. Like that, and then we do the cross section. So thankfully this cross section we can just kind of steal from here. So I'll just copy up like that. Just copy from one point to the other like that. And for this cross section I will be copying from this point to this point, but now it's not reaching it. But I can kind of just do scale 1D, right? Scale one direction or one dimension from this point to this point, and now you need to reach here. Bam. So now I have a bunch of stuff that I can work with. Okay. One last thing is adding a line segment here. You know, for these 2 rails. For these 2 rails, we'll have a line segment here. And just to keep things consistent, I will also be adding a segment here. That's it. Now we're done with the initial setup of the curves, right? From here on out, it's smooth sailing. From here on out, it's gonna be quite easy to work. All we need to do is just do the sweep to, SubD sweep to. SubD sweep to. Select first rail. This guy, let's say. Select second rail, this one. Cross-section curves. That. And that. Enter. And it looks like crap. And the reason why it looks like crap, it doesn't have enough resolution for it to not look like crap, right? So all we need to do is where it says adjusted rail segments, right here, I will just increase it. And the more I increase it, the more accurate it becomes. So I'll do, yeah, 16 seems okay. I'll stay true to 16. And I need to remember this, that I have 16 subdivisions along my sweep. Because if I do one sweep with 16 subdivisions, another one with 12 subdivisions, third one with 88 subdivisions, suddenly they don't really join up that well, right? So it needs to have the same amount of subdivisions. Topology is going to be the biggest struggle while working with SubD geometry, that's for sure. Kind of having that count of how many polygons you have in each direction. I hit OK, I have my surface again, right? We continue. So now I have, actually let me lock it in place so that I don't accidentally select it. And now we will do, again, now I'm going to do 2 more sweeps that are going to be a little bit faster. Sweep 2, or rather SubD, sweep 2. First rail, second rail, cross-section curve, enter. Magic number 16, OK. Select lock, and again, sweep, SubD sweep 2. First rail, second rail, cross-section, enter. 16 subdivisions, OK, done, right? Go ahead. Sweep 1 only uses 1 rail. So basically, if you have something like this, something like that, and you have, just really quickly drawing out an example, sweep 1. Then it asks you just for 1 rail and any amount of cross-section curves, and then it kind of tries to guess how they should be arranged. With sweep 2, you have much more control because you're kind of placing the curves in between the 2 rails. So it's much less guesswork for sweep 2 to work properly. That is why I never use sweep 1. I always use sweep 2. It just gives you much more control. Is it clear? Okay, good. So now I have these 3 SubD forms. I will just select them and type in join them up. Join edges smooth, sure, hit enter. This is how it looks like. Let me actually select curves, cell CRV, and hide them, just so that they're not in the way. So this is how it looks like. It smooths out those edges that we had in between the panels. Those get smoothed out, while these edges right here, the creased ones, well, they stay creased. I can smooth them out as well, so I can easily just select it like so. Select all of it like so. I can remove crease and then tab, and now everything is kind of blobby, but I don't really want this aesthetic, right? I kind of liked the creases, so I'll keep them like that. If I look at it with EMAP, it kind of gives you a, well, this doesn't, but the fluorescent tube always gives you a better understanding of how the curvature behaves, as long as you can kind of read it, right? Or if you're not used to fluorescent tube, you can always do true sphere, and that, okay, in this case, even I get confused by the true sphere, so don't use true sphere. Use fluorescent tube to check. There's also like much more like other stuff that you can use, like gold, for instance, that might also be useful to check for curvature. How that works, but basically that. Right, so now we have a form, and I can start messing around with it. So the first thing that I'm going to do is I will give it a thickness, right? Some sort of a thickness. So I'll just offset SubD. Yes, offset SubD. I will offset it inwards actually, like that. So you can change the direction by just clicking on the SubD. So inwards, distance, I will, if this was 100, right? This distance was 100, I remember by moving it. So if this was 100 millimeters, so that's 10 centimeters, I will give it like 5, no, more than 5. I will give it like, let's try giving it 50, something like that. And just deleting the original shape, or delete input, turning that to yes, to get this kind of a shape, and just see if that works. Seems to be working quite well. Everything is still in order. Everything is, not messing up. You can always check if things are messing up with clipping plane, by the way. That's a tool that I use a lot when I need to check if, oh crap, I accidentally selected too much. When I need to check if the geometry that I've offsetted becomes self-intersecting. In this case, as I'm moving my clipping plane, it doesn't seem like it is. Like everything is kind of consistent in terms of thickness. So I'm happy. I'm happy with that. Right, so initially what I have created right now is a facade. A portion of a facade system, right? And this is, I wouldn't really do it this way at this stage of the design development. I think this is more of a week 3 of the design development. Like week 1, the initial concept should be done how I've been showing it up until now. You have your boxes, you have your kind of forms, and you kind of, like with clay, you sculpt them together and you see what you can build up. But then rebuilding it into what would be considered a wall, or starting to look like a wall, that would be like second pass at it. I would also kind of encourage investigating different possibilities for not necessarily paneling, but I really don't want to say effect. Mesoscale. So there's like 3 different scales. There's macro scale, there's micro scale, and there is mesoscale. So meso is in between. Micro scale is usually done through texture and through material in architecture, right? So you choose the wood grain, the concrete, the pebbles, or whatever. That is the micro scale in architecture. The macro scale is usually the form, the silhouette, right? The overall, how does the building look like in general, right? That's the macro. The meso is in between, right? So the mesoscale is the form of the doors, the window openings, and stuff like that, right? That's the mesoscale in your designs. So I would suggest going into mesoscale because usually students in architecture school, since you are both learning the program and also are asked to produce a building, you are short on time, right? So you tend to skip over the mesoscale, right? And when you skip over the mesoscale, then suddenly you start asking yourself, why the hell are my renders weird, right? I have nice textures, and I have like a nice silhouette of a building, but they still look funky. Well, that's because you don't have window frames, for instance, right? Or you didn't design how the window sits in the facade. So I really strongly suggest thinking about those 3 levels of detail and working on them one after the other, which requires, of course, faster decision making in terms of design, because if you get stuck too much on one, oh, I could do this or I could do that, and you kind of get stuck in that loop of just generating idea after idea, not moving forward, then that means you get stuck in that scale, be it macro or be it meso. If you get stuck in macro scale, then during last week of the course, you will jump into rendering, you'll just slap on materials on it and just call it a day. If you get stuck in meso scale, then again, 1 week left till the presentations, and you're just, okay, I have a pretty decent model, but the materials are just whatever, just slapped wood, I guess, everything's wood, plywood, generic. And if you get stuck in the micro scale, well, you're usually not presenting because you're still rendering. So try not to get stuck. Try to always, even if you are generating new ideas and new concepts, right? And you're trying out different things, every version of your building that you generate should be of a higher level of detail than what it was before. That way you are making sure that your building is always progressing, right? That your project is always progressing. I think that is very important, and I think that is the best way of how to mitigate stress and how to deal with stress in an architectural school is feeling progress every day, right? Feeling that you are not in a loop. That's just, has nothing to do with SubD, but just a general note that I wanted to convey. Back to SubD though. Mesoscale here would be, well, first of all, it would be the bumps. I would already start considering mesoscale. But if bumps is not enough, you can always kind of start thinking about, well, I have these kind of accents that are flowing along the facade. What if I inset them? Mode, yeah, let's do group mode, and I will give it like, I don't know, that would be 1 centimeter, right? Does that work? Oh, right. One thing, good thing that I got stuck here. If something is creased, if an edge is creased and you're trying to inset from it, Rhino doesn't like that. Rhino hates that. So if you notice that that inset edge doesn't work, then try to grab those edges that are creased, that are surrounding, and try to remove crease from them. So you are ending up with, you are ending up with blobby surface, but you will bring back the creases later on. So as you're insetting like that, you are going to remove the creases just so that it's a little bit more cooperative. Let's say it like that. So we do this, we inset the edges as groups by 10. Yeah, 10 seems okay. 10, and then we have kind of these edges done, and we can't really extrude them. I want to push them in, right? I want to have these kind of pockets that are going in. I can't extrude because they change direction, right? They are twisting. Extrude will not work. So I need to be more creative, and I will use extract surface. So I'm basically getting these and I'm extracting them from the rest of my SubD geometry, right? Like that. And I will just select these, and for now I'll just isolate or hide the big wall thing. So I have these two surfaces here, or SubD surfaces, and now I can start messing around with them. So what I'm gonna do is I will, for instance, I want this to be a pocket, right? As I mentioned before, a pocket that goes inside. I can do offset SubD, this object and this object, enter, to the other side, right? Inwards, offset inwards. solid yes, delete input, whatever. Let's just agree to this, except for distance. I know that my wall thickness is 5 centimeters, so I can't have 5 centimeters of a pocket inside of my wall, because that's just going to kind of break the geometry. So my distance can be less. I'll do like half of it, 25. Like that. So I have this now as a solid block, and I still have the original SubD surface, so I'll get rid of them. And now if I were to select these two on these two ends and basically select the whole row in between them and just delete, I have a pocket now, right? So basically I just made a box. Think of it this way. I made a twisted box and I just removed the top of it, right? And now I'm going to kind of place that box back into my wall so that it's kind of a pocket, kind of an incision. This is not the only way of how to do it. And I'm not planning on showing you all of the different ways of how to do all of the different things in SubD. That's impossible. But this is just for me to show you how I think when dealing with SubD, right? And how you might think when dealing with SubD. So I have these two pockets now done. I'll do show selected and select my wall, enter. And now I just need to join them up, right? Join everything up. That, hit tab. This is now how it looks like, right? So I have a different kind of a aesthetic now to what I had before. I can kind of start working on it even further. I can go in here and say, well, I'm not sure if I want this sharp edge. Basically, this edge right here, you can see it's in bold line, and also this is in bold line. Actually, the whole perimeter of this whole ribbon is bold, meaning that all of this is creased inwards. That looks kind of cool. I like it, so I'll keep it. But one thing that I don't like is how rounded it gets on the corner here. So I'll try to fix it, or at least make it less rounded. So I'll just select these two edges here and bevel them. And I will not give it a number. I'll just kind of bevel them by, by eye for now, like that. Oh yeah. You need to crease these two edges now, because after beveling, you just created these two edges, right? So they're not creased. So you need to crease them. Crease. Tab. So now this is sharper than this. And I feel like this looks a little bit better than, again with the bananas, huh? Very easy in SubD. So that. And also kind of investigating what else I can do. I can kind of, let's say if I select this edge and the opposite edge on the opposite side of the wall and double click here, I get the chain of these edges, right? How do I show you? Maybe like this. I get this chain of edges and I can crease them just to see what's going to happen. I'm interested. That's kind of cool. That's kind of neat. Yeah, I like that. So I'll crease the top one, the top portion as well. Just like that. Crease, enter, tab. So slowly but surely, I'm moving back to a little bit more like organized or hard surfacey model, while now having a little bit more of a detail here, right? And if you were looking at this, if I slapped on some tiled, like glazing material, some nice HDRI image and so on, it would just be any other, architecture, modern architectural render, right? With these kind of surfaces. So it's really easy to arrive at a pretty high high resolution, I guess, model with very simple tools, right? And the only question is for you as designers is what kind of spaces and what kind of form are you going to wrap around with your facades, you know, and your surfaces, your SubD surfaces. So again, that's the main question right now. Any questions from you while I'm finishing up with the bevels and so on? It can be also course related, not necessarily SubD related. No, okay. Okay. Oh, there we go. Buildability as in, will it stand? Or there's two sides to buildability. First is will it stand? Second, is it possible to construct? I would argue that everything is possible to construct. It's just a matter of money. Will it stand is another one. You should be considered about its standing, right? It needs to be viable. It can't be, you know, just science fiction and you say magnets, right? That's not what architects do. The money part, though, oh, trust me, you'll have your whole life to deal with that part. So here, just have fun, right? So it can be hard to build. That's okay. But it does need to stand properly. And I mean, if you look at cantilevers, right, how much things can extend. If you look at examples, mostly Calatrava, I guess, you can get some really insane cantilevers, right? Like 50 meters, you can do that, right? It's, of course, you would need like counterbalances and proper anchoring and probably some wires. Would basically you would start building a bridge at that point, but you can do 50 meters. Well, as long as no one walks the whole distance and doesn't start jumping there. But you would be surprised how much can be built. I always show, let me find it. Fry Otto. He was an inspiration for my master's course. When I was doing my master's project, my master's degree project. Fry Otto is a tent guy. he did a lot of really cool tents, and the modern architects like Zaha and so on, they got inspiration from Fry Otto quite a bit. He's famous for his bubble tests. So he would test how fabric will behave with soap bubbles, right? And we will be kind of touching upon this a little bit in our second part of the workshop or of the webinar. But basically, bubbles and tensile structures behave in a very similar way. They will, once you tension a fabric, it will work in a very similar fashion. So he would make these kind of bubble models to test out possibilities, and then he would actually kind of make fabric models, and then he would freaking build it. Why not? YOLO, you know. And it worked. I mean, the work that he's done is beautiful, I think. Like, oh, come on, very low resolution. Let's try again. I accidentally saved it, of course. Now it's breaking. Come on, cancel. Every time I want to show you something, it just breaks. There we go. So, you know, stuff like this. Cables, cables on top of cables on top of cables, and everything is just, you know, spanning insane insane distances. So it is possible. Many things are possible to do. You just need to choose the correct material to do it. But this is not what I wanted to show you. The thing that I wanted to show you is one picture from FryAuto that I find very, very, very cool. And that just kind of shows the lightweightness and the strength of the structures. Let me try this. FryAuto spanning the future. Oh, not that, not that, not that. Oh, please. Okay, let's try it. One more. Give me 15 more seconds, or half a minute. If I can't find it, then we will skip it. FryAuto guy walking on tent picture. Oh, there we go. Sure. That's how you Google things. So there's just this guy, just, you know, a guy who kind of was fixing some stuff of the tent, just walking down. I mean, this is I think it's either in Munich, in Munich, or maybe somewhere else, but it's gardens, like royal gardens, I believe, like a dome for it, and, you know, a guy just walking on air. I really like this picture. I think it's kind of inspiring. Right, so that's that. Questions about the elements, these kind of elements, or about any kind of procedure that. Oh my God, a student with a thought. No, that's always bad. Go ahead. More than that. More than that, because right now you will be working with SubD and basically testing out possibilities and testing out form ideas that you have. And I assume all of you have some ideas, you know, for the form, even without the metaphor or anything like that. So you're just basically testing out the ideas and sketching, literally sketching in 3D. After the metaphor workshop that we will have next week, no, week after that, after the metaphor workshop, your forms will need to have a little bit of a visit. You'll pay a visit to them, and you will kind of distinguish which forms can be used to, can be altered to represent the metaphor that you've chosen. So for instance, let's say you're working with a metaphor of desertification, right? Sustainable development goal that deals with desertification, right? It's one of those. And your metaphor is, let's say sand dunes grow, so you say metaphor is growing, right? Like increasing or overwhelming. Let's say that's the word that you will get from the metaphor workshop is overwhelming, right? Then you look at your sketches and you think which of these could be repurposed or could be changed and used to work with an idea or a concept of one thing overwhelming another thing, right? And let's say you have, you know, one tower modeled out, you have some sort of 2 pavilions modeled out, and you have some sort of a long boy, a snake modeled out, right? So maybe you will then choose the one that has 2 pavilions, right? In your sketches, the 2 pavilions, and you will make one pavilion eat, as if it's eating the other, right? So it's going to be like a second pass. The metaphor workshop is going to make you do a second pass at your designs and choose from all of the sketches that you've done the one with which you will be working. Not necessarily nice. I don't think looking nice is important at this stage. That you would like to work on. The sketches? Yeah, sure. We would like to see them, but we would also like to see, of all of the sketches, the one that you chose to work with, right? The one that you will be continuing the work with. And also we would like to hear why, right? What's the thought process, right? Why that sketch and not another one? Honestly, it can be something as simple as I just like it, right? I like the sketch and I like it the most, and that's fine. But if you have some sort of a deeper, for the lack of a better word, underlying concept or underlying idea of why that sketch with that metaphor, then for sure tell us that. But we will be talking about the final, about the review, the first review that we're going to have. We'll be talking about that quite a bit during our after Easter week, right? During that whole week, and you will be kind of, you'll know exactly what to present. Well, no promises though. Maybe not exactly, but you will have a list, let's say it like that, of what needs to be presented. So for now, it's just raising your skill level, right? To keep up with your like ideas. What you want to do and what you can do needs to be at the same at the same plane, right? More questions? Mm-hmm. Yes, there is going to be a help list for tomorrow, but it is going to be a shorter one. I will be sending out an email later today with the link to the YouTube video, that we're currently recording, and to the help list. And that is the moment where I will be updating when the help list is going to happen. It's a tricky week, and it's gonna be a few more tricky weeks because I have a few courses running at the same time. Right now, I have another course that's just running, and then students are just working. So there's a little bit of juggling involved, and I will need to kind of adjust everything to be able to kind of give you a decent time frame for Friday. But there is going to be one, for sure. Okay. If there's, well, I'm always available through email, right? So in terms of, by the way, not creasing the inside and creasing the outside gives you two very different aesthetics. That's nice. A blobby boy and a sharp boy. Oh, and I always do this, I know, but just kind of working with it this way, being a little bit impatient, let's say, and just kind of creating one component and then in a very crappy way just forcing it with another component and just seeing what kind of effects you might get, in a room. That is also a viable way of how to sketch, right? Like that? No. No, you need a pretty clean topology to do that. But is it possible to merge them like that? Of course. You can always let's say up until here, right? I will not be, come on, if I manage to select them properly. So first of all, you need two holes, right? That have the same amount of faces connecting to them. One, and then you need on the other side the same amount. And I have no idea how many I'm using, but I'm gonna try and guess probably until here. I would be counting. No, not definitely not until here. More. Come on. There we go. That. Delete. Actually, let's count. 1, 2, 3, 4. Well, 1, 2, 3, 4, 5, 6, 7, 8. Again with the 8th. Lucky number 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 and 8. And now I just kind of select this loop, the opening, and select this opening, and I just type in bridge. Right? Bridge. I can give it one extra segment so that it's a sharper bridge. Hit OK. And now they are starting to connect into one big happy shape. Right? That is how I would go about this bridging. As I mentioned before, topology, very important. If I had 9 polygons here and 8 polygons here that are open, it wouldn't bridge properly. It would kind of make a mess, a little bit of a mess here. And now it works. And now all you need to do is just figure out how the hell do you do you close this thing off? Do you do something like, actually I want to check 1, 2, 3, 4, 5, 6, delete. And what if we 1, 2, 3, 4, 5, 6, 6, delete. Click, Control Shift, click, bridge, and that works. Okay. Okay. So we're slowly building up our our weird building here that has some sort of a entrance to the roof, I guess. Actually, it looks pretty cool. Anyway, more questions? Very good question. Windows. Think of Windows, like especially in this not high class, but highly experimental architecture. Think of Windows as just openings or shafts in the wall rather than punched holes in the wall, right? So this can be a window for sure, right? What I've made here. And later I would kind of model out a plane that would be glass, or I would probably model out a separate piece of geometry that would have divisions, you know, for the window frames and whatnot. And I would place it in here, but I would need to, of course, solve the planarity issue of it. And it would be a challenge in itself. But Windows, in this case, I would probably say that, you know, that these strips are windows, probably. I would never do, you know, this kind of a building, and then you do box, you know, and you just kind of make a freaking window with Boolean difference, right? That is a very fast way of how to, first of all, destroy the integrity of the form, because the box doesn't follow any kind of curvature or anything like that. Second of all, when you have a surface that is curvilinear, that is twisting, and you punch a hole in it, the opening is also going to be twisting, right? That means no proper window will fit. So you, even by trying to kind of place, a Revit window inside of here, no, it will not fit. So I would suggest thinking about windows as openings, yeah, as just openings in the wall. And you can kind of be a little bit cheeky about it and just, for instance, these two edges or these four edges, I can say I want the skylights here. I want the skylights here, so I can just select these four edges and I can slide them. That is breaking pretty bad, and it stopped breaking. Well, it's not working there. Okay, so I need to do it one by one. So I just slide these two edges towards here so that they're closer, like that. And I take these edges, move, I just slide them towards, oh my God, so much snapping involved. Slide them here so that they're closer. So now I have these four faces here that I can inset. And I'll just say group mode, sure, that's fine with me. 10 is 1 centimeter, that's fine with me. And I just delete, right? So now I have like a little frame for me to eat up my my mess. That inset basically eats up my topological mess that I'm making. But now I can just select the two holes and properly bridge them together. And initially what I've just done is a hole in my building that still follows the curvature. Well, right now it follows the curvature in the wrong direction, but it still follows the curvature of the building, right? And it's kind of located in the part of it. I would need to fix this though. This is a weird thing. A dimple. I guess that's how it smooths out, huh? Anyway. Make sense? Okay. That was a good question. More good questions? What if we do that? I'm just kind of messing around. Might be something. If it's a bridge here, might be something cool. Okay, if there's no more questions, then we are going to call it a day. Well, go ahead. It's gonna take 2 hours to process, to kind of stitch everything together, and it's gonna take another 2 hours to upload it. So at least 4 hours. So 6 o'clock, 6:30, something like that. Okay, so then I'm gonna start freaking rendering out the video just for everyone to be able to review it. Cool. I'll send you guys an email. Okay. Take care.